Imagine a city of 20 million people, and almost none of the water it drinks is actually made there. It arrives from hundreds of miles away, through a handful of pipelines, crossing one of the most dangerous fault lines on Earth. When that fault finally slips, the shaking will last about 2 minutes. The thirst that follows could last most of a year. This is the story of what happens to Los Angeles after the big one. Not during it, but in the long, brutal aftermath most people never think about. And by the end of this video, you'll understand why scientists say the earthquake itself is the easy part. Southern California is one of the most heavily populated regions on the planet, and almost none of that is an accident of geography. The desert basin that Los Angeles sits in was never meant to support millions of people. It was made livable through sheer engineering, decades of aqueducts, tunnels, and reservoirs built to drag water in from hundreds of miles away. Today, more than 70% of the water Southern California depends on is imported. It comes from the Sierra Nevada mountains, from the Colorado River, from watersheds far outside the region. And to get all of that water into the city, engineers had to find a way through the mountains that separate the desert from the coast. There's really only one practical route. It's a narrow mountain corridor called the Cajon Pass. And here's the problem, that pass is also where the San Andreas Fault runs. So the aqueducts don't avoid the fault. They cross directly over it, along with major fuel pipelines, high-voltage power lines, and rail corridors, all bundled together in the same tight stretch of land. When the San Andreas Fault finally ruptures in a major event, it isn't a small shift. Sections of ground on either side of the fault can move past each other by 20 feet or more, in a matter of seconds. Steel pipelines are strong, but they aren't designed to stretch that far, that fast. They rupture, not in one place, but potentially in dozens of places along the same line. Engineers who've studied this exact scenario estimate that fully restoring water flow to Southern California afterward could take anywhere from 4 months to a year and a half. Not days. Not weeks. Months, possibly more than a year. Now stretch that timeline across a region of 20 million people. Firefighters trying to stop urban fires with little to no hydrant pressure. Hospitals rationing water for surgery, for sanitation, for basic patient care. Families surviving on bottled water that was only ever meant to last a week, not 16. The financial damage from the water outage alone is estimated in the tens of billions of dollars, and that number doesn't even include the earthquake damage itself. The people who actually run this system know it better than anyone. Engineers at the Los Angeles Department of Water and Power and at the Metropolitan Water District that manages the imported supply have said the same thing for years. The greatest danger isn't the skyscrapers downtown. It isn't the homes built into the hillsides. It's what's buried under the streets, the pipes nobody sees, the crossings nobody thinks about. A city that cannot make its own water is only ever as safe as the thin lines bringing it in from outside. And every one of those lines runs straight across a fault that is going to break. To understand the true scale of this, scientists built a detailed simulation known as the ShakeOut scenario, one of the most thorough earthquake studies ever conducted for a major American city. Here's what they found. Roughly 1,800 people killed. About 50,000 injured seriously enough to require emergency care. Hundreds of thousands of people driven out of damaged homes, some permanently. And total economic losses estimated around $200 billion, with some projections placing it even higher once long-term disruption is factored in. But the researchers behind the ShakeOut scenario wanted one message to land above all the statistics. The earthquake itself isn't the disaster. It's the opening act. The real damage, the fires that can't be fought without water pressure, the hospitals that can't function without power and clean supplies, the transportation and fuel lines severed at that same narrow mountain corridor. That's where a major earthquake does its slowest, most lasting harm. A region can survive 2 minutes of violent shaking and still be brought to its knees by everything that unfolds in the weeks and months afterward. Most disaster documentaries end with the same warning: this could happen again. This story is a little different, because that phrase doesn't quite apply. It hasn't happened yet, Not this version, not at this scale, not in the modern era. The honest answer isn't that this earthquake might happen someday. It's that it will happen. The only variable science genuinely cannot give us is the date. The U.S. Geological Survey puts the probability of a magnitude 7.5 or larger earthquake striking Southern California at around 36% over the next 30 years. For something magnitude 6.7 or larger, the odds climb to well above 90%. The stress along the southern San Andreas Fault has been building for well over a century without a major release, and by some geological measurements, the accumulated pressure is now higher than at almost any point in the last 1,000 years. Seismologist Lucy Jones has spent much of her career trying to make one simple point land before the ground actually moves. This isn't a matter of chance, it's purely a matter of timing. There will be no meaningful early warning before it happens. And the only real window for preparation is right now, during the calm, while people and institutions still have a choice. She has argued, repeatedly, that the entire point of studying a disaster this closely isn't to frighten people into paralysis, it's to make sure fewer of them get hurt when it finally arrives. The difference between a catastrophe and a survivable event isn't decided in the 2 minutes of shaking. It's decided years earlier, in which buildings get reinforced and which systems get hardened while the ground is still calm and quiet. And that's really the point of this whole story. Out of nearly every kind of natural disaster, this is one of the rare ones we can see coming years, even decades, in advance. That means the damage isn't fixed in stone. A large part of it is negotiable. Buildings across Los Angeles can be, and in many cases already have been, retrofitted to survive stronger shaking, though officials admit the work is far from finished citywide. Water systems can be rebuilt using flexible, ductile pipe that bends instead of shattering under stress, paired with backup routes that don't all funnel through that same narrow corridor at once. Neighborhoods and individual households can stockpile stored water and backup power sources ahead of time. Families can keep enough emergency supplies on hand to comfortably get through the first hard weeks without depending entirely on outside relief. This is exactly why, every single year, millions of people across California take part in the Great ShakeOut, the largest earthquake preparedness drill on the planet. Not because the drill prevents the earthquake from happening, but because preparation is genuinely the only variable left in this entire equation that remains within human control. Think about it this way. On any ordinary day, none of this feels urgent. The freeways are full, the faucets work, the lights come on. That's exactly why preparation is so easy to postpone. There's no visible countdown, no siren warning you the pressure underground is building toward its limit. But that quiet is the opportunity. Every retrofit completed now, every backup water tank installed now, every emergency kit packed now, happens while there's still time to do it calmly and deliberately. The alternative is trying to do all of that in the chaotic hours after the ground has already moved, when it's far too late to matter. It's worth remembering that behind every statistic in the shakeout scenario is an ordinary household, a family trying to figure out where their next gallon of clean water is coming from, a hospital staff rationing supplies between patients, a small business owner watching months of lost income pile up while roads and rail lines stay severed. Disaster planning can feel abstract until you picture it at that scale: one street, one family, one decision made or not made years in advance. That's the level at which this entire story actually gets decided. The fault is loaded. The pressure has been building for generations. And the city sits directly on top of it. None of that is up for debate. What's still uncertain, what remains genuinely open, is how ready the region will actually be on the morning the ground finally moves. This isn't a prediction with a date attached to it. It's a certainty about the future, with the timing deliberately left blank, and the preparation left entirely up to us. If this story was worth your time, drop a like, leave a comment, and consider subscribing. It genuinely helps this channel keep making videos like this one. Stay safe out there. Keep a little water set aside. See you in the next one.